As we know, Python is a dynamically typed programming language, which means that the type of a variable is determined at runtime, not at compile time. This feature allows for more flexibility and rapid prototyping, but can also lead to errors that are difficult to catch and fix. To address this issue, Python introduced type hinting in version 3.5, a way of annotating code with hints about the types of variables and function arguments. In this video, we explore why this matters and how it can enhance your Python programming experience. The primary purpose of type hinting is to make code more maintainable and easier to understand. By providing type annotation, developers can more clearly communicate the intended types of data in their code, which can reduce confusion and improve collaboration. Additionally, type hints can help catch errors at development time before they cause issues in production code. Type hinting in Python has several advantages. It can make your code more self-documenting, allowing other developers to more easily understand the purpose and expected behavior of functions and variables. It can help catch errors early in the development process, before they cause issues in production code. Type hints can make refactoring code easier by helping developers understand the flow of data in their code. In addition, type hints can help catch subtle errors that may be difficult to catch with traditional debugging techniques. Finally, many modern integrated development environments, IDEs, and code editors can use type hints to provide improved autocomplete, code highlighting, and other features. Let's start with basic type hinting for function parameters and return types. Here's an example where we use int to specify that both x and y should be integers. Here, we use list and dict from the typing modules to specify the expected type of the data argument. In addition, we use tuple from the module typing to specify the expected type of the return value. In this case, a tuple of two int numbers. Python does not include built-in type checking functionality. However, there are third-party tools that can perform static or dynamic type checking based on type hints. These tools can detect type-related errors, such as type mismatch, before the code is executed. Some popular type checking tools for Python include MyPy, Pywrite, and PyCharms. The following example demonstrates how type checking works with MyPy, a static type checker for Python. First, we need to install MyPy using pip. Pip install MyPy. Then we can create a file named example.py with the following code. In this code, we are calling the times function with two arguments of different type, 1 and 2 as a string. The program would run without any issues, but we may not have the expected result. This might prove difficult to debug in a larger project. However, if we run MyPy on the code, we get the following error message. Type hinting.py for error argument 2 to times as incompatible type string expected int. This error message indicates that the second argument to times has the wrong type, string instead of int, as specified by the type hint. The static check provides us with invaluable information without even running the code. Python type hinting system goes beyond basic types and allows for more advanced type hinting to enhance code readability and maintainability. The union type is used to indicate that a variable can have multiple types. It is a way of expressing that a variable or parameter can be of one type or another. This is particularly useful when a function or variable can accept a range of data types. The union type is typically used from the typing module, and it is applied by using square brackets. The syntax looks like union, square bracket, type 1, type 2, and so on. Let's consider an example where a function takes a parameter that can be either a string or an int. The usage of union allows the sum-digit function to handle both integer and string without causing a type error during static analysis. Union provides flexibility in specifying that a parameter or variable can accept more than one type. It makes the code more explicit by indicating the expected type of data. It's commonly used when a function or variable can handle various data types, enhancing the versatility of the code. However, while union is powerful, it is essential not to overuse it. Consider using more specific types when possible to maintain code clarity. The optional type is used to indicate that a variable can either have a specific type or none. This is useful when you want to specify that a function parameter is optional and can be omitted. The optional type is part of the typing module, and it is often used in scenarios where a variable can have a specific type or be none. The syntax for using optional involves using the keyword optional and specifying the type within the square brackets. Let's consider an example where a function takes an optional parameter that can be either a string or none. In this example, the greet function takes an optional parameter name of type optional str, indicating that it can be either a string or none. If name is provided, it returns a personalized greeting, otherwise it defaults to a generic greeting. When specifying a default value for the parameter, it is entirely valid to provide a default value other than none. The optional type indicates that the parameter can take a specified type or be omitted, defaulting to the provided default value if omitted. Let's illustrate this by refactoring our previous example. Here, the greet function takes an optional parameter name of type optional string, indicating that it can be either a string or the string stranger. The default value for name is set to stranger, providing a default value other than none. Valid usages include providing a specific name or omitting the name parameter, in which case the default value is used. This pattern is commonly used when you want to allow a parameter to be optional but provide a meaningful default value if it is omitted. In Python, type hinting, typedict, is a class provided in the typing module that allows you to define a dictionary with specific key-value pairs and their corresponding type. This is particularly useful when you want to enforce a certain structure for dictionaries within your code, providing better static analysis and documentation. The basic syntax for defining a typedict involves creating a class that inherits from typedict and specifying the keys and their type as class attributes. For example, we define a user profile class inheriting from typedict, where username, age, and email are the expected keys with their respective types. The print user profile function takes a parameter user of type user profile and prints the user's information. When using the user profile type, the code analyzer ensures that all required keys with their specified types are present in the dictionary. If a required key is missing, or an additional key is present, or if there is a type mismatch, it raises a static analysis error. Typedict helps enforce a specific structure for dictionary. It provides better static analysis during development. Use typedict when you want to communicate and enforce a specific structure for dictionaries in your code. Using type hinting can greatly improve the readability and maintainability of your Python code. However, simply adding type hints is not enough. It is important to follow best practices to ensure that your code is clear and consistent. Here are some best practices to follow when using type hinting in Python. Be consistent. Consistency is key when it comes to type hinting. Make sure that you use type hint consistently throughout your code base. This means using the same style of type hinting and being consistent with the name and types of variables and parameters. Use descriptive variable names. This will make it easier for others to understand what the variable is for and what type it should be. Use type dictionaries. They are a great way to define a dictionary with specific key value pairs. This can be useful when working with APIs that require specific input formats. Finally, it is important to be precise with the type being used. This means avoiding generic types like any, and instead using more specific types like list of string or tuple int string. This helps make the code more self-documenting and easier to understand. In the ever-evolving landscape of Python programming, the adoption of type hinting has emerged as a transformative practice, offering developers a valuable tool to enhance code quality, readability, and maintainability. Type hinting serves as a form of documentation, making code more explicit and self-explanatory. By providing insight into variable types, function parameters, and return types, developers can quickly understand the expected structure and behavior of the code. One of the major advantages of type hinting is its role in catching errors early in the development process. By incorporating type annotation, developers can identify potential issues during static analysis, preventing runtime errors and enhancing overall code robustness. Type hinting acts as a communication tool among developers working on a project. It facilitates collaboration by clearly defining the interface between different components, making it easier for team members to understand and contribute to the codebase. Type hints play a crucial role in making codebase more adaptable to changes. During refactoring, developers can rely on type annotation to understand the flow of data and make modifications with greater confidence, minimizing the risk of introducing errors. However, it is important to note that while type hinting is a powerful aid, it is not enforced by the Python interpreter. Developers should view type hints as a guideline that enhance code quality, but not as a strict rules governing behavior. The flexibility of Python remains intact, allowing for a balance between clarity and flexibility. In conclusion, the adoption of type hinting represents a significant step forward in the evolution of Python. Type hinting, when used judiciously, becomes an integral part of the Pythonic journey, enriching the coding experience and ensuring the sustainability of Python projects in the long run. Thank you for watching, and see you in the next video.